Hello everybody. I wanted to take you guys through how to use S&C's free protection analysis tool, Coordinaide, to develop very professional looking transformer protection curve documentation for our course and for any other time you find yourself having to do so. S&C's Coordinaide is an excellent tool. It's a freely available tool, but it's a very particular tool in how it expects its data to be provided to it. If you don't give it the data exactly the way you want it, it might not behave as anticipated. And so to start out with that, I'd recommend you guys check out the user's guide. The link's here on the information button, and it'll bring you to a very nice PDF document that covers all the different aspects of S&C's Coordinaide and how to use it and how to get data into it. Now, let's go through a couple of early gotchas. First, everything in Coordinaide is referenced against three-phase values. For our class, I've been referencing everything against single-phase values. So, everything has to be converted over to a three-phase reference. I'm going to be going with values for current from our example number 2 in the lecture today. So we had gone with 4.8 volts, so we're going to have to update that to be 8.3 volt kV. Now, available fault current, this field here just sets how wide this red bar is. It's assumed when you're doing protection analysis that sources can't deliver an infinite amount of current, and you set this value to match what your source can provide. The assumption is if it's in that red zone, it doesn't matter. The source can't get you that amount of current anyway. So you can leave it as it is, or you can set it for 20,000 amps. If you've got interactions going on higher than that, you can leave it higher than that, unless I give you specific details on what I want to see in that value. Now, once you have this section set, you can click Add Device. Once you hit this Add Device, you cannot go back and then change these values, so it's important that you set them up first. If you find that you've junked your project and you have to start again, you can click on these 3 dots and there is a Delete Current Project button that lets you scrap it and start from scratch. It also lets you download your project when you've got something you're happy with and then re-upload it again later so you can keep working on it or regenerate it. So we've got things set the way we want. We're happy. We can hit the Add Device button. Now, I wanted to cover another gotcha before we moved on. You might find in this list that we've got a transformer damage curve. It's a chosen option. Isn't that marvelous? We can click on that. We can set our connection to YY like we use here in Ontario, and look at that, magnetizing inrush points. Glorious. We plot that and we see the inrush is looking really promising, but that damage curve is not. S&C uses a different methodology. Remember, we're using the IEEE standard behavior for damage curves. IEEE, or this S&C Coordinaide tool, uses something different. Now, so because of that, we're not going to be able to use the transformer damage curve. We're going to have to develop those curves by hand using a different tool. Now, another gotcha. Once you have a transformer in this list, you can't just delete it and carry on, because it's going to reference everything else on this list against that transformer's secondary, meaning you're going to see some very peculiar behavior. Once we've added this to our list, the only way to make sure we get the expected outcome, delete the current project and start from scratch. So that's what we're going to do here. And now we can start adding the devices that we're actually going to use. And for what we're going to do for our damage and our inrush lines is we are going to use the user-provided data import tools. So what this lets us do is it lets us upload whatever we want, and it'll plot it on the graph for us. It's a very powerful function, and it's referenced in the user's guide. You'll find the manual on page 43 of what it's expecting. And what it asks you to do is generate a comma-separated value file. And so what you can do is you can get out your favorite spreadsheet. I'm using Excel today. You could use Google Sheets. You could use it's comma-separated values. You could use a notepad, text editor if you wanted. And what we have to do is we have to develop this file to the specification that S&C has given us, which is current in column A or column 1, time in column B, column 2, and we can have as many rows in here as we want. So I've taken our inrush values from example 2, I've written them into this table, I've saved it as a CSV file. So if you're doing this in Excel, when you go to save, you go File, Save As, and you have to set your type of your file to CSV, comma delimited files. If you save it as an Excel document, Coordinaide won't know what to do with it and your import will fail. So I've got one of these put together for inrush. I already built up a second one of these for the damage file. So that one's ready to go as well. So back to Coordinaide. So we can give things a name. We can set color. Our inrush curve was going to be black. We wanted our type to be line, so it could be points, a line, or a polygon, which would allow you to do like a custom fuse behavior with a shaded region in the middle. We're going to hit the import curve data button, and then we're going to import the file that we had just made up, our CSV file. And if we hit the plot button, it'll update the graph, and there we go, a very fine looking inrush curve. So we can add a second one of these. Device type user provided. Let's make this one red. Nice looking red. We're going to call that damage. Make that a line. And we can attach our damage file. We can open that up and import it. And now we've got both of our lines displaying on the graph. If we want to go back, we can click on each one of these and it'll bring us to that one so that we can set our values. Next up, we can add our expulsion fuse. So you're going to find your expulsion fuses under the fuse link button. So for device type, go to fuse link. And for manufacturer, you can choose S&C, although for your expulsion fuses, you're going to find that a number of the manufacturers make the same style fuse, which makes sense when we talked about standardization, allowing many manufacturers to make interchangeable parts. So, in honor of S&C, we're going to go with the S&C fuses since they were kind enough to provide this tool for everyone's use. And we've got our K speed as well as our T speed, which are the two styles we're going to be using. If you recall, I mentioned there were a number of families of expulsion fuses, but we were going to limit our studies to these two because more than that just added complication without actually adding a lot of value to the course. So as you poke around in Coordinaide, you're going to stumble across all kinds of other styles of fuse. Please hold it to the K and the T. If it's K dash something or T dash something, or if it's anything other than a simple K and a simple T, probably wiser to stay away from it. So we were going with our K-speed fuse, and then that'll give you the list of all of the fuses that were in our series. I believe we opted for a 25. We aren't going to play with preload or ambient temperature for now. We might come and see those later in the semester. And if we plot that, we can set our color. I'm not really digging the purple here, so yeah, I like the teal. The teal looks good. And we can see, just as we had gotten in the example in the lecture, we've got a little bit of interference going on here near the top for our damage curve, and we miss our inrush curve, and that's sitting up pretty nicely. So we can add our last device, our NX companion. So we're going to add one more device to our chain. And you're going to find the NX companions under the current limiting fuse option for device type. So I believe you find them under Cooper-McGraw. Yeah. So Cooper-McGraw is one of the manufacturers who makes an NX companion. So we're looking for an NX companion. Regardless of what voltage, we make a lot of simplifying assumptions in this course, so regardless of what voltage you actually have, always pick the 8.3 kV minimum, and always pick the 23 kV maximum, whether that's valid or not. That's one of the things that we're neglecting in the course lectures. And that will allow you to select your 3 fuses. So we had chosen the 40. We aren't going to concern ourselves with the set black allowance at this time. If we update our plot, you can now see our fully complete graph. All of the elements that we're looking for. We have a damage curve, an inrush curve, an expulsion fuse with minimum and maximum clear, and a current limiting fuse with minimum and maximum clear. The regions in between are shaded. This is a beautiful and complete graph. You can change the color if it's calling to you. And this is complete. And this is ready for submission in a homework or a major assignment. If you submit a graph that looks like that in a major assignment, you're definitely going to be getting full marks for it. From here, we have some choices. So we can download the PDF summary. And if we open that up, we'll see that we've got a nice PDF showing us our graph. So we got a PDF copy of our graph as well as details on all the items that we selected. It's important to note that this PDF does not actually include labels for anything. So if you're going to be submitting this, you might want to find a way to make sure that the fuse links are actually labeled correctly with a little bit of post-processing. Same here, if you're taking a screenshot of this, you're going to have to do a little bit of post-processing to make sure that your fuse links have appropriate labels on them. The other thing that you can do is you can download your current project. So if you download the project file, that allows you to start from scratch. And instead of hitting add device, you can just choose upload project. This is a project that I had put together earlier. You hit the upload button and there it is. The entire thing comes back, remembers all your settings, and you're ready to pick up where you left off. So this is an introduction on how to use Coordinaide. Worth learning the gitches and gotchas to produce some very professional looking output. Hope you consider using it. If not, check out the other video where we're going to be going over how do we do this with by hand, or how do we do this using a computer graphics program. The outputs from there are completely acceptable for submission in this course, but as a rule are going to be a little less professional looking. Have a great day, and as always, if you have any questions, please don't hesitate to contact me. Thank you.